Hello everybody. Today, me, Yousef Altanak, and my partner Aziz Boyabis will cover a brief introduction to acidizing. As we know, there is a damage in our wells that should be removed, and acidizing can be one of the most effective ways to remove it. But first of all, what is acidizing? Acidizing is unsteady, non-isothermal 3D flow in porous medium with chemical reactions needed to dissolve the rock. As I said, it's a chemical reaction, so there is a chemical product that has a precipitation and also the solution to the rock matrix. And these two can cause a continuous variation in the porosity and the permeability of the porous medium. But our goal today here is to enhance the well productivity, reduce the skin factor since it would stimulate our well, and the solution of scale deposits in the fractures.
Hello. So, how do we know when we use acid treatment? Well, basically, when we have damaged our reservoir and when we damage our formation and near wellbore area, we need to use acid treatment. How do you know that you have damage? Basically, we run PLT, which stands for Production Logging Test, and downhole camera, and also we run well testing analysis. So from well testing, for example, in these two curves, as you can see, for a rapid decline in here. So what's that actually mean? So rapid decline is basically fine immigrants travel to your well, it choked your well, and it choked your permeability. It will have a sudden decrease, rapid decrease in your production. And another one is you will have a gradual decline in your production. So when you have a scale deposit, for example, is scale deposit doesn't happen in one night. It gradually happen through the time. And now we're gonna talk about type of acidizing, type of acid stimulation. So I'm gonna talk about the MAC acidizing, and my partner Yousef is gonna talk about fracture acidizing. So for MAC acidizing is that it's basically we want to inject our acid below the parting pressure. So what does that mean? It's basically we don't want to frac our formation. So when we inject acid reacts with the minerals inside the pore. And for example, for carbonate acidizing, acid react with carbonates and create holes like branch. As you can see from the drawing, this phenomena called wormholes. And it's also the skin factor of it. We can go below zero. We can go below zero, which is negative value, and we can go to also zero. So also we have sandstone acidizing, which is just washing washing the formation and we can go skin factor to zero.
So, for type 2, we have fractional acidizing. And simply, fractional acidizing is the opposite of matrix acidizing. Since it is above the parting pressure, and as we know, the etching can help to remove the damage, but here also it can help to see the fractures, providing the stimulation. Now, I will go through the acid types with you. We have 4 acid types. I'll start with the inorganic acids, and we have HCl and HF, and we have organic acids, which are acetic acid, formic acid, and citric acid, and we have blends, which is a mix between an inorganic acid and inorganic acid, or an organic acid and inorganic acid, or organic acid and organic acid. So basically it will go like this: HCl, which is an inorganic acid, with HF, which is also an organic acid, or formic acid with the hydrofluoric acid, or citric acid with hydrofluoric acid. Also, we have special acids. For example, the aminocarboxylic acid, or the GLDA, or GLDA. So now, I'm gonna talk about the hydrochloric acid, since it has a lot of advantages. One of the most important advantages is that hydrochloric acid is very, very cheap compared to other acids. And also, it has a high dissolving power, and it has a concentration that varies from 3% to 25%. And also, its products are water soluble, which is very important for our case. And now, I'll let Aziz take over.
I want to mention one more thing about what my partner said about the concentration. The optimum concentration is about 15%. So the reason why is that there's no benefit of having about 15%, especially economically. So for the reaction rate, when HCl react with the carbonate, it will give us salt, which is soluble in water, which is what we need for renewable acid for the concerns. So, as you know, hydrochloric acid is very reactive, and as you know, most of our equipment are made of iron. So when we inject our acid inside our pipe, it will have a lot of corrosions inside of our pipe. So what's the solution? We need to add a corrosion inhibitor to it. And also, as you know, that it's very reactive, especially in high temperature. So when we inject acid to our formation, it will not go deeper inside the formation. So we need to add additive like organic acids to make it go deeper inside our formation. Other problems is that when we have a lot of clays inside our formation, is hydrochloric acid is not a good friend with clays, because it will break it, and it will break it in such a way it will make it fine immigrants, and it will damage our formation. And also, when we have heavy oil and iron, if we inject acid, we would have slug and asphaltite precipitation, which will damage our reservoir. So HCl cannot dissolve or react with organic materials. So the solution for that is we need to run solvent. So the conclusion is that hydrochloric acid is very cheap, but it needs a lot of additives that will make it expensive. So now I'm going to talk about hydrofluoric acid. Hydrofluoric acid is known for sandstone reservoir. Why? Because it is the only acid that can dissolve the silica, and it's also is it has higher it's very reactant than hydrochloric acid. So when we inject hydrofluoric acid to a calcium carbonate, it's not good. It will react some substance that's not soluble in water, and it will do more damage than remove the damage. So what we're gonna do, how do we solve it, is by pre-flush hydrochloric acid and then inject hydrofluoric acid after that. One thing I have to mention is that we cannot inject hydrofluoric acid and HCl and HF together simultaneously, because HF is very high reactive and it will react with calcium carbonate very quickly, and then it will result this substance which is called calcium biofluorine. So then this substance HCl will cannot dissolve it and make it soluble. And the other thing is that when hydrofluoric react with sandstone reservoir, it will be, as you can see, that it will be soluble in water. So now, one of the problems that we face is that when we inject hydrofluoric acid with when we inject hydrofluoric acid, and there is sodium and potassium, these two elements are not soluble in high pH. So what's the solution is that we have to inject HCl to reduce the pH to negative, to become like 0, and it will make these two substances soluble inside the formation. So after that, we're gonna face another problem, which is that we cannot take these materials back to the surface in low pH. So we have to also inject organic material to raise these to pH 1 or 2, to raise it to pH 1 or 2, and then collect them back to the surface. Now I'm going to talk about organic acid. So when do we need to use organic acid? Well, basically, when there is a long acid contact time. What does that mean? So when you have acid inside inside the pipe for a long time, this will result very corrosions, especially if you inject acid, especially if that acid was HCl. So what you need is inject the organic acid instead. And also, organic acid is very good ion control. So, for example, when you inject acid, into our well, we inject organic acid also. So what that will do is that it will make the iron, it will keep it it will keep it from going into the solution, and it will prevent it going to the solution, and from that it will not go to our formation, and it will then create asphaltene participation. As you know, that organic acid is the known are formic acid, acetic acid, and citric acid. So now I'm going to let my partner take over the presentation.
Oh, so now these are some examples of the acid additives that we were talking about. So we have a corrosion inhibitor intensifier, anti-sludge agent, iron chelating agents, retardants to prolong the effect of the reactive agents further in the fractures, and different solvents according to the treatment of the formation. And this is the acid placement, and we have two types, which are mechanical and chemical. Some of the mechanical are coil tubing, tackles, bridge flags, ball sealer, and all of these, the mechanical ones, they would dissolve the damage that is near the weld bar area, but in fact we would like to also to go deep inside our formation and dissolve all the damage there as well. So that's why we need the chemical bar to help us to go deep inside the formation and dissolve all the damage. Also, there is a phenomenon that is called diversion, as you can see here. So this figure here is, shows a good example of the permeability differences in our formation, and I can tell this is the highest permeable area. And in the diversion phenomena, that when we inject the acid, it would go always to the high permeability sections of our formation, but it will never reach the low permeability or the medium permeability sections. So that's why when we inject the acid, we would do it on in a pattern of stages. For example, first of all, we would inject the high permeable area. After that, we would inject some gel to cover the high permeable area and work as a wall to make us able to inject the medium permeable area. And we would also, after injecting some acid in the permeable area, we would inject gel as well to block the medium permeable area. Then we would inject the lowest permeable areas and remove all the damage. Thank you very much. And this presentation was done before by Professor Ahmed Al-Goma, who studied in Texas. He's a great professor, and he actually has a video about it as well in BioPetro on YouTube, and you can check it there. And this is the website, and he would explain everything there in depth.
And that's Yousef, and that's me, Aziz. And today we talked about the acidizing, and thanks for watching.